Origin History of Capacitor. The capacitor was first invented in 1745 by Ule Georg von Kleist and independently in 1746 by Peter van Muschenbroek of Leiden, Netherlands. Their device was called the Leyden jar. It was the earliest form of a capacitor and could store electric charge for experiments. Later, different types of capacitors were developed for use in radios, computers, and electronic circuits. Definition of capacitor. A capacitor is an electrical device that is used to store electric charge and energy in the form of an electric field between its plates. Working of capacitor. A capacitor consists of two parallel metal plates separated by an insulating material dielectric like air, glass. When the plates are connected to a battery, the positive plate gets positive charge, and the negative plate gets equal negative charge. The insulator prevents direct flow of charge, so charges remain stored on the plates. When connected in a circuit, the stored energy can be released to do useful work. Mathematical form of capacitor. The ability of a capacitor to store charge is called its capacitance. C equals QV, where C equals capacitance of the capacitor. Q equals charge stored on the plates. V equals potential difference voltage between the plates. C unit of capacitor. The SI unit of capacitance is the farad F. 1 farad is defined as a capacitor has a capacitance, a charge. 1 coulomb C is stored when the potential difference of 1 volt V is applied. 1 farad equals 1 Celsius of 1 V. The farad is a very large unit. So smaller units are commonly used in practice, such as microfarad F. Looks at C video how capacitor working here 3D animation.
A capacitor is similar to a battery in that both store electrical energy, but a capacitor is a much simpler device that can't produce new electrons. It only stores them. However, capacitors can do things a battery can't, as we'll show here. For the purposes of this animation, we'll focus on different parts of the current propagating through the wires at different times. When we close the switch, electricity immediately runs throughout the circuit. Although the convention is to think of electrical current as moving from positive to negative, electrons actually move from negative to positive, as we represent here with yellow particles. As you can see, the battery is not much good at powering this motor to lift this weight, because it discharges gradually, much more slowly than would a capacitor with the same charge. Here we'll learn why a capacitor is much better suited to such a task than a battery. Like a battery, a capacitor has two terminals, positive and negative. Inside the capacitor, the terminals connect to two metal plates separated by an insulator that keeps the plates from touching each other and allows them to hold opposite charges, maintaining an electric field. Capacitors can be useful for storing and quickly discharging electricity, so you can power, for example, an electric motor as we'll show here. First we need to charge a capacitor. By closing the switch, we create a circuit that includes both the capacitor and the battery. Electrons flow from the battery to the capacitor where they are stored. Here, a yellow glow represents the increasing charge held by the plate. For every electron gained by that negative plate, an electron is lost by the positive plate, maintaining the capacitor in equilibrium. Here, the red glow represents the positive charge held by the plate that increases with each parting electron. The capacitor continues to charge until it attains the voltage of the battery charging it. Now that the capacitor is fully charged, let's put all that stored energy to use. By connecting it to a new circuit, we can power a small motor. This electrical current powers the pulley to lift a weight until the charge dissipates. The electrons on the capacitor's negative terminal are drawn to its positive terminal. They rush along the path that leads there, straight through the motor. Let's watch this again. Even though the battery and the capacitor attempted this task with the same amount of charge, only the capacitor successfully powers the motor lifting the weight because it discharges much more quickly. This feature makes capacitors useful for powering things that need a quick surge of energy, such as flash bulbs and cameras, and starter motors and audio amplifiers in your car.
Subscribe subscribe to my YouTube channel Muhammad Hamzat Muhammad HAMZ-EB. Thanks for watching.